So hello, good evening all.
So hello, good evening all.
One second, guys. So is my voice audible? It was echoing. Actually, I've connected through two devices. So for chatting purpose, I'm using my mobile, guys. So that's why I was getting echo. So good evening all. So anybody of you started installing Hadoop system? Anybody is tried to install Hadoop system on your system? I'm not getting any response. Is my voice audible, guys? So is my voice audible? Yes. I was asking you something, right? So have anyone tried to install Hadoop ecosystem on your system, on your own system? Say yes or no, guys. Why I'm not till now, sir. Arup, we are very close to the examination, right? So it will take some time to install on your systems. So better you all try to install on your systems, guys. Otherwise, try to uh, look into virtual system. So try to work on virtual system. So better you all install on your own system, guys. So I want you people to understand the configuration behind it. Okay, once you understand configurations, then definitely I'm going to tell you guys, you can resolve any errors. Otherwise, you people will face problem. So Hadoop is not like a ready-made system. Okay, the one who working on Hadoop, they are not going to use the ready-made system. So they have to install, they have to understand what and all changes we are doing. So based on that, so in future we are getting any errors miss, then easily we can solve it. Okay, guys. Okay. So hello everyone once again. So a warm welcome to all of you to our sixth session of Big Data System course. And it is great to see very few people. Okay. So very few people attending today's session. And yes, but the 18 people I'm looking at what my system. So they're all very much excited to listen for today's class. Yes, guys, before we begin, as usual, so I want to share a quote by John Nesbitt. Okay. The quote is, the new source of power is not money in the hands of a few, but information in the hands of many. Okay, so this quote truly captures the essence of what we are learning in this course. So it is about empowering ourselves and organizations with the ability to handle and gain insights from massive amount of data. My dear friends, so over the last few sessions, so we have laid the groundwork by understanding the fundamentals of big data, its challenges, and the need for new systems to handle it. So today we are going to build on that knowledge and get our hands dirty with the core of our Hadoop ecosystem. Okay, so we'll explore the Hadoop architecture, its key components, and we will delve deep into the Hadoop distributed file system. So that is nothing but HDFS. So let's begin with our first slides, guys. So before that, let me ask you one thing. You are all ready for today's session? You all ready for today's session? Shall I get quick confirmation on chat box? So once you people are ready, please do type ready on chat box. And if you have your own WhatsApp group, means put a message on WhatsApp group, guys. The class is started. Okay. So I want more people to attend today, because today I'm going to show you very, very important concept for your examinations. Practical thing also I'm going to show you guys. So for that reason, I want maximum attendance. So please do inform to your friends. Thank you, Seni. Seni is very much excited. Okay, guys. Yes, last class we have left with a few slides, right? So let me complete all these slides first. And later on, we will move to the Hadoop ecosystem. Guys, actually, we have left with the iterative MapReduce concept. Okay, we have to start from iterative MapReduce concept. So let's kick off today's session by talking about a very important concept that is called as iterative MapReduce. Okay, so see, look at here, guys. You can see in the very first point. So we have understood that MapReduce is a one pass computation. So what does that means, guys? It means a MapReduce job typically processes the data from its input and performs the map after map. So it will call reduce function and then writes the output. Okay, the job is then complete and it is a what? Single linear run. But guys, in the real world, many applications, especially in the areas like machine learning and data mining, so need to process data iteratively. So think about it, guys. So when you are training a machine learning model, you don't just run the algorithm once, right? So you often need to go through multiple cycles or iterations of the data processing to refine your model and make it more accurate. So these applications demanding for the what? Iterative executions of MapReduce job. Correct, no? A common approach to this is we have to create a what main function. You just look at here, guys. Look at the diagram. I'm going to what explain you in detail. Okay. So we have to what create. The very first thing is we have to create main program, and this main program. Okay, this main program acts as a driver. Okay, so this main program acts as a driver. Are you getting my point, guys? Or we can call it as orchestrator or monitor. So what it is going to do, guys, actually it is mainly sits on top of the core MapReduce framework and repeatedly calls the MapReduce job with a new set of data. So hope you are all understanding. Okay, the core program also needs a mechanism to check for convergence. Okay, so can anyone tell me what is convergence? What do you mean by convergence? You have understood that concept, right, already? What do you mean by convergence? Club all results. Okay. Is it club all results? Okay, common point. Very good answer. So it is the point. It is the point where your algorithm has reached a stable state and further iteration won't significantly change the result. Am I right or wrong, guys? That is called as convergence, right? See, for example, in a clustering algorithm like K-means algorithm, you might stop when the change in the cluster centroid in below a certain error bound, or you might just run it for a what? Fixed number of iterations. So in essence, you are wrapping a simple single pass MapReduce inside a loop. Okay, the output of the iterations becomes the input for the next. So that is called as iterative map reduce concept. I think now you people are all understanding what exactly mean by iterative map reduce. Yes or no? Can I get quick confirmation on chat box? See, you can observe in this diagram. So this is the main function. See, look at here, guys. Very first time, what this main function is doing. So see, inside the main function, we have put this map. So this mapper function is executing. This mapper function is going to generate key value pair. So this key value pair will pass to reduce. So see, reduce is also producing some output. This output, see, look at here. This output will become input to the main function again. Okay, so this output is called as variable data. But very first time, so we have given input as a static data. Are you all getting my point, guys? Initially, we have given static data as an input. So what mapper is going to do? So mapper is going to create a what key value pair and it will produce that output to reduce. What reduce is producing, guys? Reduce is producing variable data. So that will become a what? Input to the main program. So this will be what? Keep on looping. So this will be keep on looping, correct? No? So this map step and a reduce step. So which is our standard map reduce job. Easily you can analyze, right? What is happening here? The map functions take some input and reduce function process it. So now see, arrow mark is very, very important. Look at the arrow marker coming back from the what reduce step. So this is the arrow mark coming back from the what reduce step. So feeding into the what main program's loop. So this is the key. The output from the reduce step becomes the input. And what we are calling it as a what? Variable data. For the next iteration of the what map reduce job, the static data is data that does not change. And it is also fed into the what mapper function. Okay, the main program then checks a condition or convergence check. So if the condition is not met, the loop continues and we iterate again and again. Okay, so let me take you one small analogy, guys, to explain on this. So imagine you are trying to find a perfect recipe for a dish. The first time you cook it, you get some feedback. So based on that feedback, you tweak some ingredients. Understanding my point? So, but keep the core recipe as it is, right? What is that core recipe? That core recipe is nothing but your static data. Okay, you repeat this process, cooking and tweaking. So until you get a perfect dish, at which point you have converged. So that's the exactly how this iterative process works. So this model allows us to perform complex iterative computations by changing together multiple map reduce jobs. Okay, so now let's look at the one classic example, that is k-means clustering algorithm. Okay, so are you aware of k-means clustering algorithms, guys? Can you all quickly chat and put a chat message in chat box? Are you all aware of k-means clustering? No. Okay, many of them are saying no. Have you not learned machine learning concept? Okay, let me try to give you idea on k-means algorithm, guys. Look at the diagram. You will understand what exactly it is. So I want you people to focus on this slide then. Okay, look at here, everyone. I want each and everyone to look at here. Guys, k-means is an algorithm. Listen to me carefully. K-means is an algorithm, machine learning algorithm, used to group similar data points together. Okay, so here we are using the value k, right? What do you mean by k? So k in k-means refers to the number of clusters. So this is number of clusters. So you want to find actually. So see, as you can see in the very first image, look at the very first image. So we start by randomly selecting k initial, means are centroids. Do you know how to calculate means? How to calculate centroid? So there is a mathematical formula for that, right? Yes or no? So we are using means or centroid to calculate the what? Number of k value. Okay. So now in our example, what is the k value? In our example, so we are taking k is equal to 3. So we are considering k is equal to 3. So what are the three, guys? So one is showing in red color, another one is showing in green color, and third one is showing in blue color. So blue colored dots. So in the second step, see, this is the very first step. This is over. So we have identified k value by using means or by using centroid, and the k value is equals to 3 now. Okay. In second step, so we create k cluster. How many clusters we are creating? We are creating 3 clusters by assigning every single data point to its nearest centroid. See, nearest value. So for this, so I'm taking this value as a nearest value. Okay, for this, I'm taking this as a what nearest value. So we are going to perform some mathematical calculations, guys. Okay, so based on that, so we are going to find the nearest centroid. Okay, you can see the what different regions here. Look at here. This is one region. I have divided this into 3 regions. So this is second region and this is third region. So we have divided it into what 3 regions here. So we can call it as Voronoi diagram. This is also called as Voronoi diagram. So that partitions the what data. So each point belonging to the what cluster of its nearest centroid. This is the second step, guys. In second step, we have divided it into what? 3 different partitions. Okay. Now we will move to what third step. See, in third step, so we calculate a new centroid. Okay, we are going to calculate our new centroid for each of these newly formed cluster. Okay, the new centroid is simply the average position of all the data points assigned to that cluster. So this new centroid is now the new mean. So this is the new mean value. Okay, so that is what exactly we are going to do in the third step. So finally, we have fourth step, guys. You can look at here. So in fourth step, we repeat step 1 and step 2. Okay, so we reassign all the data points to their new nearest centroid, and then we recalculate the centroids. So we keep repeating this process until the centroid no longer moves significantly. So which is when we have reached convergence. Okay, so see the patterns here. So it is an iterative process which makes it a perfect fit for our interactive MapReduce model. The output of one iteration, okay, that is the new centroid, becomes the what input for the next step actually. So hope everyone understood what exactly we are going to do in k-means algorithm. Guys, actually in what 5 minutes I tried to what explain k-means, but you people not having any knowledge on that means you have to go and Google it, guys. This knowledge is mandatory. So hope this is clear to everyone. Is this clear? Shall I get quick confirmation? Shall I get quick confirmation? Okay. So only one person is typing yes. What about others? Now look at here, guys. Now I'm trying to what explain. So K means as iterative MapReduce. This is very, very important concept. So now we came back to what our MapReduce concept. Now let's map the what K-means algorithm onto our iterative MapReduce model. Guys, you can see in this slide the MapReduce program. Look at here. So we have a what MapReduce program. This is the complete MapReduce program. Okay, so it is what responsible for this iterative program. Within each iteration, so we have map and reduce step. So this is C. This is your user program, right? This is your user program, right? So here we have what? Mapper and reducer program. iterative mapper and reducer program. So let's think about what the map and reduce steps would do in this context. Guys, in map step, we all know what it is going to do in map step, guys. So each map task would take a data point and the current cluster centroid as an input. So here centroid point is the input actually, and also along with that it is taking all the data points. So its job would be what? To compute the distance from that particular data point to each cluster center and then assign the data point to the closest cluster. Understanding my point, guys? That is the main job of mapper. Okay. And it would then emit, see what it is emitting. So it is emitting key value pair. So after performing that, it is emitting key value pair where key is the cluster ID. Okay, let me write here. So key is the cluster ID. So it is going to show which cluster we are using, and value is the data point. So value is the data point. So this is the key value pair I'm going to get as an output from this mapper function. Next, what do we have here, guys? So we have a reduce function. So the reduce function would take all the data points assigned to a what particular cluster ID, and its job to compute the what new cluster center for that cluster. Guys, this is done by averaging all the data points received, and the reducer would then output the new cluster center. See, it is computing new cluster center. Okay, so this is where the magic happens, guys. The output from this reduce step, the newly computed cluster center, becomes the input for the next mapper function. See, look at here. So this will go and it will become a what input for the next mapper function. Correct? No? The user program then checks for convergence. See what this user program is doing. So it is checking for the convergence. So it initiates the next iteration. So feeding the new cluster centers back into the what mapper task. So this is a fantastic example of how we can use one pass computation framework like MapReduce to solve a multi-pass program. Okay, so it highlights the power and flexibility of the model when you design the overarching the program correctly. Okay, so this is the best example, guys, for this concept actually. So next I'm moving into one more example. Maybe you have heard about page ranking concept. So how many of them have heard about page ranking concept? So do you have any idea on page ranking, guys? I'm sure most of you have heard about page ranking. Yes or no? Where exactly we are going to use this algorithm? Okay. So Tanya, no problem. I will explain you. Okay. Himabindu, no problem. I will explain you. So have you used Google search, Tanya? Himabindu, have you used Google search? Varaprasad Reddy? I think you all used Google search, right? So can you tell me, once you are typing any word on Google search engine, on what basis it is going to list all the websites? Otherwise, data. See, you are going to type Hadoop, correct? No. So once you are typing Hadoop, so it is going to list so many websites, right? So why it is going to show the very first one in the very first very first list? Based on page ranking. That is called as page ranking. Guys, page ranking is the algorithm that Google search engine used to rank web pages. So in its early days. Okay. So, and it is a perfect example of an iterative computation. How many of them agree with my point? Again, this is very, very important concept for your examinations, guys. I'm putting 3 stars here. Okay, this is very, very important one. Okay, the basic idea is that a web page's importance is determined by the importance of the pages that link to it. Okay, so think of it as a popularity contest. The more popular pages link to you, and the more popular see, the more popular you become. Okay, let's look at the formula. So this is the formula we are using here. The page rank of page, the page rank of page X is calculated based on the sum of the page rank of all the pages that link to it. Okay, the formula looks a little intimidating, guys. So, but I'm going to break it down and I will show you one by one. No need to worry about that. But yes, you people have to remember this formula. So based on this, we are going to calculate the page rank of page X. So what is X here? So you can observe here. So we have taken the value X, right? What is X? So X is the page we want to calculate the page rank for. Okay. And then what is this T1, T2, T3? See here we have taken TI, right? See here I'm showing you. So this is T1, this is T2, this is so on Tn. So we have so many values, right? So T1, T2, T3, so on Tn. What is this? So all are the pages that link to the page of X. You can observe here. So we have a page X. So inside this web page, we have so many hyperlinks, right? So this page is linked to T1. This is linked to T2. This is linked to Tn. Again, T1 page is linked to so many other pages. T2 is linked to so many other pages. So there is a hyperlink from one page to another page. So that is the what? T1, T2, T3, T4. Okay. And you can observe here. So we have taken PR of TI. What is this PR of TI? So it is the current page rank of that page TI. So this is the current page rank. See, let me check with this T1. I have taken T1. What is the page rank of this T1? I'm going to what? Use it. What is the page rank of T2? What is the page rank of T3? So current page rank, we are going to what? Get the information. And below this, we have C of TI also. What is the C of TI? C of TI is the total number of outbound links on page TI. So this is nothing but the out degree of the what TI. You just look at here, guys. What is the out degree of this X? See, it is 3, right? See, look at here. So it is connected to T2, it is connected to T1, it is connected to Tn. This is called as the out degree of Ti. So that is nothing but C of Ti actually. The total value we have taken here. And below that we have N also. What is this N? So N is the total number of pages in the corpus. Total number of pages. N is nothing but total number of pages. See all the information we have mentioned here. Okay. Then what is this alpha? Guys, this alpha is probability of random jump. Okay, probability of random jump. A concept used to prevent dead ends in the web graph. So it is damping factor, guys. So this typically set to 0.85. So usually this typically set to 0.85. Try to remember this. 0.85. So notice that to calculate the what page rank of X. So we need page rank of the pages linking to it. So this creates a circular dependency. So which is why we need an iterative process. Correct? No? Without iterating process, we can't solve it. So we start with the initial page rank for all the pages and then we refine it in each step. Okay. So let's understand the what iterative processes. What are the iterative processes we have? This is the very first step, right? So we have to what start with the initial page rank value for each node. So we can simply give every page a rank of 1 by n. Okay. So then see after that, then each page distribute its current page rank credits to all the pages to link to it. And what is the third step? Each page then adds up all the what credits it's received from its inbound links to compute its new page rank value for the next iteration. And finally, guys, we iterate this process until the page rank value converge. Correct? No, till we get what? Till we reach to the end. So we keep on what iterating it. The meaning of this is we don't change much from one iteration to the next iteration. That you should understand. Guys, this is the classic iterative algorithm, guys. So make a note of this. This is very, very important one. So as PageRank is fundamental algorithm in search and prime example of an iterative computations in big data. So hope everyone understood what exactly this PageRank problem is and how we are going to use iterative concept. So is this clear to everyone? Shall I get quick confirmation on chat box? Next slide, I will show you PageRank as an iterative process here. So I'm going to show you one diagrammatic representation. So that will give you more idea on this concept. Shall I move forward, guys? No doubts, right? Till here, everything is clear. Till here, everything is clear. Shall I get quick confirmation on chat box? I'm not receiving any responses. So can you explain once again in short? In short, okay, I will show you the diagram. So next slide, I'm explaining you in short. See, what is the C of T? Here I've told you, right? What is C of T? What is C of T? Can anyone tell me? I have written here. What is C of T, guys? C of Ti is the total number of outbound links on this page. So this is the page. This is the current page. So the outbound pointer, see how many are going out from this. So what we are going to call it as, guys, in mathematics, we are going to use this, right? So we are going to call it as degree of that particular node. See how many edges are passing from here. This is called as a degree of that particular node, right? The same thing is C of Ti here. Total number of outbound links on page Ti is called as C actually. Is this clear? Total number of hyperlinks. Yes, exactly correct. So in real time, it is a total number of hyperlinks. So from one page to another page actually. Yes, exactly, Jyoti. Your answer is perfectly correct. Okay, now look at here, guys. Look at the diagrammatic representation. So this will give you more idea on the same PageRank as a what iterative map reduce. Okay, so let's see how we can implement PageRank using mapper and reducer. So it is a what similar in what spirit to our k-means example. So you can see in this diagram, guys. So we have a clear mapper step and also reducer step. Okay, so in map phase, so each map task would work on a specific page. So you just imagine. So this is page 1, this is page 2, and this is page 3. So this is particularly on what, guys? Specific page. Correct? No? Its job is to take the current page rank. Okay, current page rank of that page and list of its outbound links. Okay, just imagine the page rank of this page 1 is 10. The page rank of this page is 1 actually. So this is 4. Along with this, so it is taking outbound values also. Look at here. We are taking outbound values also. Okay, so the mapper will then calculate the page rank credit so that this page will distribute to each of its linked pages. So it will be keep on continuing, guys. Again, it will go and check what everything. Okay, so it will emit a key value pair for each outbound link. Where what is key here? What is key value pair here in very first step? So what is key, guys? Can anyone tell me what is key? Key will be always your target value, target page, and the value is the page rank credit. So this is page rank credit. Page rank credit being sent actually. Okay, this is the key value pair is going to what take by each and every mapper and reducer. So next we will move to what next step, guys. What is the next step? Next step is reducer step. So each reducer will receive all the page rank credits for a what single page, and its job to what gather up all these credits from the multiple sources and compute the new page rank value for that particular page. It will gather all the informations. It will take the rank of all the values and average it, and then it is going to give a what? New page value. Okay, so just like your k-means, the output of the reduce step, that will be always giving what? New page rank value. That will always give new page rank value for this particular page. So this will become again input to the what? Mapper step. So input to the what? Mapper step. Correct? No? Are you getting my point? So we keep iterating until the values converge to the what? Stable state. So this is exactly what the iterate until convergence loop in the what diagram signifies. See here, we have clearly mentioned. So this model is simple, powerful, and shows how you can use one pass framework for a multi-pass problem. So however, there are what some significant overheads, guys, that comes with the what? Comes with this approach that we will discuss later. So we are not talking about any of the what? Overheads here. So we are trying to what understand how pager and ranker problem are going to solve by using iterative mapper and reducer. That's all. So now is this clear to everyone? Somebody were asking about what? Clear information on this, right? So is this clear to everyone? Yes, now you are all getting point. Okay, guys, look at here. Iterations using existing runtimes. So we have established that a basic approach to iterative MapReduce is to implement a loop on top of a what? Single step MapReduce framework. Okay, so like Hadoop. So this is often called the driver program approach. Okay, this is often called as driver program approach. Try to understand this. Okay, while it works, it comes with some significant overheads that make it inefficient, especially for applications like machine learning that requires many iterations. Then you can ask me, right, sir, what are those overheads? See here, all the overheads are listed. Okay, so what is the very first overhead, guys? What is the very first overhead? So look at the diagram. Try to understand the diagram. See here in this diagram, we have taken while loop. Look at here. So we have taken while loop. So this while loop we have taken inside the main function. So in each iteration, we are essentially running a brand new MapReduce job. Correct? No? So this is the brand new MapReduce job we are running here. Okay. So this means there is a lot of wasted effort and resources. The main overheads are, the very first overhead is reinitializations of the task. Correct? No. So every time we start a new MapReduce job, so we have to span a new set of map and reduce tasks. So this takes time and consumes resources. Yes or no, guys? Is it not the one overhead we are going to face, guys? Yes or no? And the second one, see, look at here. Every time we are reloading of static data. See here, you can observe. This is the static data we have taken here. Okay. So this static data being loaded in every iteration in our k-means example. So this might be the entire data set. So loading the same data over and over again from disk is highly inefficient. Correct? No? Every time it is loading means it is highly inefficient. And finally, the third disadvantage or overhead is communication and data transfer. Guys, after each reduce phase, the output is saved to the multiple files on disk. See, look at here. After this step, reduce step, the data is loading on different files on disk. This data then has to be read back in the next iteration. Okay, this constant disk input output and data transfer across the network adds a lots and lot of latency. So this data is transformed from disk to the network and then back to the disk again. So this will be what keep on processing, right? So this is a very expensive process, guys. Guys, in terms. So it is like rebuilding an entire factory every single time you want to produce a what new batch of products. Okay, so it is functional, but it is not fast or efficient. So this led to the development of new and more optimized framework. So which we will discuss later. Okay, that I will tell you later. Okay, later or next slide only I'm going to tell you guys. So hope you all understood, right? What are the disadvantages of using this iterative mapper and reducer? Yes, yes, not in Hadoop 2.x. I will show you. Can you wait for a while, Anup? Arup, sorry. Okay, now look at here, guys. I'm showing you one new product. So MapReduce++. So guys, because of the massive overheads we just discussed with the basic iterative approach, so researchers and developers started looking for optimization. So this optimization led to frameworks like MapReduce++. So which are designed specifically for iterative computations. Okay, the key idea is to what? Do some optimizations on top of the existing model. What are these optimization? The very first optimization is static data loaded once. Guys, instead of reloading static data in every iteration, the new framework are smart enough to what? Load it just once and keep in a memory or cache memory. So this significantly reduces the what? Disk input output. Am I right or wrong, guys? So we have started using caching concept here. So is it the best way of what? Overcome the very first overhead, what we have seen in the previous methodology? Yes or no? And next one, look at here, guys, cached task across invocation. So instead of reinitiating task in every iteration, the map and reduce task are designed to be what? Long running. Correct? Now, why I have to start again and again? So let it what? Run for a long time. So they are cached, are kept alive. So they don't have to be what? Spun up from scratch for each iteration. And the third one, look at here, guys. We are using a new methodology that is called as combine operation. So this is again very, very important concept, guys. Okay, this is very, very important one. So combine operation, the frameworks also introduce a new operations. That new operation is called as combine operations. So why it is useful? It is used to collect all the reduced output. See, look at here, you can observe. We are not storing data inside the what? Any disk. So we are storing, see, this is the combine. Combine is going to collect all the output from the reducer. Okay. So they also use faster data transfer mechanism. So avoiding the what? Costly disk to disk transfer we saw earlier. So is this a good one, guys? So you can see the same thing in diagram. The main program is still in a what? Loop. Look at here. The main program still in a loop. But now it is much more efficient. There is a configure. You can observe there is a configure step that happens only once at the beginning to set up the what? Static data and also task. The communication between the mapper and reducer phases is much faster here. The combine operations always help to aggregate result before writing them. So reducing the amount of data returned to the disk. Guys, this is one of the what? Greatest example of how a simple but powerful idea in this case. So building a framework that assumes and optimize for iteration. So it can what? Drastically improve performance of the system. How many of them will agree with my point? What the purpose of configure? Just now I've told you, right? Jyoti, I just now I've told you, right? Is this clear? Configure is the step. So we are going to run at the beginning. Okay. So it will take the static value and also task at initial step. So that is the job of configure. Is this clear? Okay. So now let's take one small example. Okay. Example in Twister. enable more APIs. You just look at this example, then you will understand. So this diagram shows a more detailed view of a system like Twister. So that's optimized for iterative MapReduce. What it is highlighting, guys, it highlights the key differences from Nave looking on top of Hadoop approach. So here you can see, so we have main program processes space. So inside it, we have configure maps. Look at here. So we have configure maps, configure reduce functions, correct? No? So these are the two functions called once at the start, and they start up and long running. And these two are cacheable map or reduce task on the worker nodes. Try to understand. So this is going to load on worker nodes. You have to remember this because I'm going to show you next. So this avoids the overhead of reinitialization that we discussed earlier. And now look at here, guys, we have a while loop. Next to that, we have a while loop. So inside while loop, inside while loop, we have run map reduce. When run map reduce is invoked, the key value pair can be sent directly to the worker nodes. It will send directly to the worker nodes, guys. Understanding my point? So what it is bypassing? So this is bypassing the need to write them to the disk, correct? No. We are not writing data back to the disk. Directly it is pushing that data to the worker node. So this is because the map and reduce tasks are already running. So, and it is ready to accept a new data. And next to that, very, very important thing is the communication or data transfers are direct via pub sub broker network. Okay. So by using pub sub broker network, so we are going to perform communications or data transfer, or we can use direct TCP. So here we have mentioned, or we can use direct TCP. So this is the huge performance again. Okay. And next to that, we have a combine function. You all can observe here. So we have combine operation. Combine operation is also shown here, right? So what exactly the job of this, guys? Collecting all the reduced outputs. So after each iteration, the main program updates its condition and decides whether to continue iterating or to exit. Okay. The main takeaway here is that by rethinking the architecture to be loop aware, these frameworks can dramatically improve the performance of iterative algorithms. Okay, they are much more efficient for machine learning concept, guys. Otherwise, you are performing so graph mining. So then it is very much useful. Okay, otherwise you are performing multi-pass computation. So then it is going to play what vital role. So if it is pub bar subnetwork, that means so it is a kind of event collection. What do you mean by event collection? Is event collection is necessary for communication or data transfer? One is publisher, another one is subscriber. You're talking about consumer and producer concept, right? Ravi, have you heard about direct TCP? What is the role of direct TCP? TCP means what? Transfer control protocol, right? So there is no restrictions to TCP here, means then it will become pub sub broker network. So we can perform communications directly. No, we are using direct TCP. It is almost. Okay. Now, guys, look at here. The optimizations indeed help. My dear friends, as the old saying goes, the proof is the pudding. Okay, this slide presents a graph that shows the performance difference between various programming models for k-means clustering task. You can see here. So we have y-axis. So y-axis shown as what? Average time for 16 iterations. And x-axis is shown as number of data points. Okay, here we have two lines, right? So one is at green color, another one is at red color. Okay, so look at the green line at the top. So this represent Hadoop. Okay, this represent Hadoop. Okay, it is clearly mentioned here. This is representing Hadoop. You can clearly see the performance is very slow, taking over 1400 seconds for even the smaller data sets. You can observe here. For smaller data set, it has been taken 400 seconds. Okay, this is due to all the overheads we just discussed. Okay, constant disk input output, reinitialization of task, network traffic, so on and so forth. Now look at the other lines, particularly the blue line we have here. See, look at here. We have a blue line here. What is this blue line, guys? It is representing twister. And a red line appearing for the, where is the red line? Yeah, the red line. This is the red line, right? Dryad line queue. So they are significantly faster. So twister takes just a fraction of time to complete the same task because it is optimized for iterative computations. Okay, and look at here, guys, we have one more, that is MPI, which is showing in pink color. Guys, MPI line is even faster. So what is MPI? What is MPI? Can anyone elaborate MPI? Message passing interface, not communication, interface, right? Message passing interface is called as an MPI. So it is often used for, where we are going to use MPI, guys? Can anyone know where we are going to use this MPI? We are going to use it in high performance computing. So in supercomputer, we are going to use this, right? In distributed computing, yes. So we are going to use it in high performance computing, but it is not general purpose big data framework like Hadoop. Try to understand this. Guys, this graph is powerful illustration of why it is so important to choose the right tool for the right job. Okay, guys, I would like to guide you guys for a single pass job, Hadoop might be fine. But for iterative computations, the overheads are simply too high and you need a specialized framework there. So this is very, very important point, guys. So make sure you understand the performance implication of these different approaches. So that will always play a crucial role while selecting the particular problem. So hope this is clear to everyone. Yes or no, guys? Yes or no? Guys, beyond the specialized framework like MapReduce plus. So there are other options that have emerged to address the inefficiencies of iterative computations. So we have the very first one that is called as Hadoop. So Hadoop is an extension of Hadoop. So this is the extension of Hadoop. So instead of building a new framework from scratch, so it modifies the Hadoop scheduler to make it. And next one, we have the concept of loop aware. So inside this, we have a concept of loop aware. So it also implement caches to avoid going to disk between iteration. So which is a major performance improvement. So it is a great example of an incremental approach to optimization. But the most famous and widely used solution for this problem is Spark. Okay, so nowadays maybe you have heard about it, right? Spark everywhere. Everyone started using Spark. So I'm sure many of you heard about it. So Spark is different because it uses in-memory computation. Okay, in-memory computation is used to speed up the iterations. So instead of storing data in a files on disk between iterations, Spark uses the concept called RDD, Resilient Distributed Data Set. Okay, I will explain you more on Spark, guys, more on RDD in Spark concept. For a time being, I'm explaining you RDD is an in-memory, fault-tolerant, distributed collection of objects. Okay, because the data stays in memory, the disk input output overhead we may saw in traditional Hadoop is completely eliminated. So this makes Spark ideal for iterative computations that reuse a lot of data in each iteration. And one very good thing is Spark RDDs and in-memory approach are game changer for machine learning and other iterative algorithms. And it is a huge step forward in performance and also efficiency, guys. Okay, so that same thing I've used to explain the page ranking algorithm here. You can observe. So this is the page ranking algorithm we have used here. So it is called as Neve page rank using Spark. I'm giving you a little bit hint, guys. So by giving some lines of Java code. So if you don't know Java code, no need to worry about that. This you can analyze later. For a time being, we just go through this, guys. So here I've taken a snippet of what a simple PageRank algorithms look like in Spark. Okay, so here we are using Java API. Okay, here we are using Java API. Okay, look at the code, guys. Look at the code. So we first load data from the file. Look at here, the very first line. The very first line. So we are loading data from the file. See, we have taken text file. So we have taken the function, inbuilt function Spark read. So by using this, so we are loading data into Java RDD. It is very easy to understand, guys. Okay. And this data text file should be present in HDFS. Don't forget this. See, initially you have to store this file inside the HDFS. So from HDFS, you're copying the data. Okay. So this is creating Java RDD of lines. Okay, of lines. Lines means line by line. So when see, we then transform this into Java pair RDD. Look at here. So inside Java pair RDD, we have taken string and iterable string both. And we are calling this as a links here. So we are calling this as a links. This RDD essentially represent our web graph. Okay. So this is our web graph. Try to understand this. So this is like your web graph. Okay. So with each key value pair being a what page and list of pages, it links to. Okay. So what is first string? So first string is taking the page. And the second string is taking the list of pages to links to. So we then see what after this we are going to do, guys. So we are going to group the links by key and cache the result. Key and cache the result. So this is very important step, guys. Caching the RDD. Okay, caching the RDD. The meaning of this is, so it will stay in memory for a future iterations. Okay, then what is the next step we are creating here? The next step is, you can observe here, Java pair RDD called, what we are calling for this. So we are calling this as a ranks. So this is holding the initial page value for each page. So initial page value for each page. Typically we are going to set to 1 actually. So we are going to initialize this to 1. Guys, the core of the iterative process is the for loop. So we are using this for loop. This is very important one. Okay. So inside for loop, look at here. Inside for loop, we first calculate the contributions of each page to its linked page. Okay. And then we recalculate the new pages based on those contributions. Understanding my point, guys? This example I will explain later. You try to understand this. Okay. So notice that. So we are just operating on RDD. So there is no explicit saving to disk, reloading from disk. I think everyone will agree with my point because we have cached it. Look at here, we have cached it. So the data is staying in memory. So which is why it is so much faster. Okay. So once the loop finishes, okay, once this for loop finishes, so immediately, guys, immediately the RDD contains the final page values. So for that, we are going to use a ranks concept actually. Okay, the ranks RDD contain the final value. This will be containing the final value. This code snippet beautifully illustrate by using illustrate the what how Spark in memory RDD streamline the iterative process, eliminating the what disk input output bottleneck that plugs the older Neve approach. Okay, you can observe in this example. Okay, you can observe in this example. See, look at the example here. So this code is linked here, guys. If you want to see the entire code, you go and click on this link. You will get the code, complete code you are going to get there. Try to understand this, guys. The slide is the reference I've taken from the GitHub, guys. That GitHub link is completely given here. You try to go through this. Okay. And this is the example I've taken. Try to understand this example by your own. So whatever the concept I've explained you, so everything is given in this example. Try to understand this example. If you are not understanding, you then come back to me. So I'm giving you this as homework problem for you people to understand. Try to understand this code. So based on that, you have to compute this. You go to this particular link, you will get all the informations. So is this clear to everyone, guys? Is this clear to everyone? And this is the summary of what previous concept, guys. I don't want to summarize this because this concept, see, I took what so many, see, total 3 hours class I've taken to what complete the session 5 concept. So now I'm jumping into session 6 concept. Okay. So now it is almost 1 hour, right? Now it is almost 1 hour, right? So shall we start with the next session concept, guys? This is very interesting concept. Hadoop architecture and file system. Yes. So even I'm thinking for that, Himabindu. Shall we go for 5 minutes break or 10 minutes break? So I will extend 10 minutes there. Is it okay for you all, guys? Yeah, 10 minutes break we can take now. Sir, is this the third module? No, module wise, I have to check in your syllabus. Let me check once whether it is belongs to third module or fourth module. Wait a minute, guys. I will show you. Hadoop ecosystem is in third module. Yes. So it is in third module. till now, whatever we have covered, that was in second module. So now Hadoop ecosystem is completely on third module. Yes. Yeah. Thank you, Saini. Yes, sir, till eighth session. So tomorrow I'm completing seventh session, and next class I'm going to complete eighth session. Eighth session we have very less number of slides, guys. No need to worry about that. So only it is on practical thing. Okay, so eighth session is going to take very less time. So seventh session is little bit huge. So we are prolonging again on MapReduce concept. Okay, so tomorrow I'm going to cover seventh session. Saini, you just go through the handouts. So in handouts, see first off, we have 8 sessions. So 8 session. So you go to next, see instead of module wise, you go to next block. So we have divided 5 modules into 16 session, right? So first 8 session for your midterm examination. Saini. So take a break, Saini. Okay, we can come back after break. So in break, I got so many questions on chat box. What are those questions? Sir, okay. Syllabus already I've told you, right? Sir, in the meantime, okay, I have a question regarding the exams. So we come to know somewhere that exams on makeup dates will be quite difficult compared to, of course, yes, sir. Of course, yes, guys. That is completely true. It is not a rumor. It is true. See, why you people are taking makeup exam? See, for makeup exam, there is a condition, right? You go through the information given on your frequently asking question. It is not easy to take your makeup exam. Okay, so to take up that makeup exam, you have to give a genuine reason. Correct, no? So what about question pattern? Question pattern is same. You have to provide a reason. Reason. Without reason, I don't think they are going to give you makeup exam. Is it? I don't know. I don't know about that. Actually, I have received a message. So once you people have genuine reason, then only they are going to give makeup exam. You cross check once, guys. Why difficult, sir? Makeup questions. Pradeep, actually, see, so before makeup exam, we are going to conduct regular exam. See, regular exam is going to reveal my pattern, right? So it is going to reveal some idea of the question paper. Am I right or wrong? See, we are focusing on, see, since it is our closed book, we are focusing on what? More on remembering kind of what concept actually. Okay, yes, you have to remember formulae, you have to remember definitions, you have to remember some concept what I've taught in the class. So based on that, you are going to get the questions. Okay, so since you people are taking 1 week extra time for preparations also, am I right or wrong? So that's why it is little bit tough. Not very tough, it is little bit tough compared to the regular exam. Even sometime regular exam will also be what tough. Okay, but previous year questions also reveal the exam pattern. No, 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 no. It is not like that. I have told you, right, Pradeep? So last time I have not given question paper. This time I'm giving question paper. Okay. So my way of asking question is different. Already I've told you, right? So I am going to give you the case studies. So you have to read the case study. Based on that, you have to answer few questions. That is my style of what asking questions. It is not direct questions. Sometime you are going to get direct questions. Sometime you are going to get case study based, scenario based questions. Okay. So till you get my very first question paper, you're not going to understand what type of question I'm going to ask. You have to understand my pulse, right? Pradeep. Okay, guys. Now the time is 7:12. So it is the time to start the next session concept, guys. So now all back, guys. So once you people are back, please do type me in chat box back. So I will start with the today's session concept. Guys, before we move into the what next one, so let me show you the glimpse of what we will be covering in session 6. Guys, here we are mainly focusing on Hadoop architecture overview. Okay, Hadoop architecture and its file system. Okay, that is the HDFS concept. Guys, it is crucial to understand the architecture of Hadoop because it is the foundation of almost all big data processing. So we'll explore the different components and how they work together to store the process massive data sets. and we will go into more details on HDFS. So which we introduced today. Okay. And so my what sincere request is, so get ready for a what deep dive into the inner working of Hadoop in our next what in our session. Okay. See next slide. See, these are the topics we are discussing in today's session, guys. So I will quickly go through this. First, we are going to look at architecture overview. Under that, we have components. And next, we are going to look at the differences between Hadoop 1 and Hadoop 2. So then we will dive into HDFS concept. So inside this HDFS concept, we are going to discuss architecture of HDFS, robustness mechanism, and we will understand the concept of blocks, replication strategy. And this is followed by very important topic, the read and write operations in HDFS. Okay, read and write operation in HDFS. And we will briefly talk about file format. And finally, we will be what wrap up by looking at some common HDFS command. Okay, this is again important, common HDFS command. Okay, so guys, this is the jam-packed session. So let's get right into it, guys. So can I get a message? You're all ready for this? You all ready for this, guys? Can I get again quick confirmation and chat box ready? Thank you, guys. So now all of you look at here, guys. Let's begin with high-level overview of Hadoop. Okay, at its core, Hadoop is a framework with two main layers, guys. Okay, first layer is called as data storage layer, and the second, see, this is a data storage layer, and the second layer is called as data processing layer. One is storage layer, another one is processing layer. Look at here, you can observe here. The data storage layer is provided by the HDFS, Hadoop Distributed File System. Okay, think of HDFS as a massive distributed hard drive. Okay, so it allows you to store very, very large files, often in the terabytes or petabytes, across thousands of commodity machines. And it is designed for high throughput and fault tolerance. Try to understand this. This is very, very important key characteristic. High throughput, and one more point is fault tolerance. I will explain you what is these two words later. Fault tolerance. These are the two characteristics which we are achieving here. So we will go into much more details on HDFS shortly, guys. So you can observe here, the next layer is called as data processing layer. So it is provided by the MapReduce programming model. So we have already spent some time on this. So it is the framework for writing applications that process large data sets in parallel on a cluster of machines. Okay, now look at the what master slave architecture. See, this is called as master and these are all called as slave. So this is the high level architecture, guys. So we have master and slave nodes here. So in Hadoop 1 architecture, the master node would have single computational component that was called as MapReduce. Single computation component actually. So that was your MapReduce actually, and a single storage component. That single storage component was called as HDFS. That is in Hadoop 1. I'm talking about Hadoop 1. Okay. And the same for slaves also, guys. But this model was tightly coupled. Already I've told you, right? What do you mean by tightly coupled? Everything I have explained you, right? So in previous session, the MapReduce framework was also responsible for resource management with a limited the types of jobs that could run. The next major version of Hadoop is called as Hadoop 2. So this has changed this completely, guys. So we will be what looking for that here, Hadoop 2 architecture. You can observe. So this is your Hadoop 2 architecture. The diagram shows the much improved architecture of Hadoop 2 here. The core idea here is the decoupling of resource management from the processing framework. Okay, so let us break down this into different components, guys. The very first one, look at the master node. Okay, on the master node, you still have name node. Try to understand this. You still have name node. Okay, I will tell you what is name node later. So, but yes, for time being, the name node is the brain of HDFS. Understand this. What is the role of this, guys? It manages the file system, namespace, and metadata. Here clearly I mentioned. So it is going to handle or manage the file system, namespace, and metadata. Okay, so it is an arbitrator, not a data handler. Try to understand this. So it is not a data handler. It is an arbitrator. So we'll discuss it in detail in the next coming slides, guys. So I don't want to give you everything here only. Okay, you have to understand. Repeatedly, I will explain you guys. At the end, you have to understand each and every concept clearly. That is the main intention. And the next one, the big new addition here is that resource manager. You can see in Hadoop 1. So we were not having resource manager, right? So one computation, one HDFS. But look at here, guys. So we have resource manager here. Guys, this component is a part of YARN. Is a part of YARN. Can anyone elaborate YARN? What is YARN, guys? YARN. Yet another resource negotiator. Correct, no? Negotiator. That is your YARN. Okay. So it is responsible for managing all the resources in the cluster. So he is the main manager, guys. That's why it is called as a manager. It is responsible for all the resources in the cluster, such as your CPU, memory, so on and so forth. Everything has to be what? Taken care by this YARN. And next to that, look at here. We have so many slave nodes here. Correct, no? So we have so many slave nodes. So each slave node has a data node. Look at here. So on each slave node, we have a data node. Okay, which is responsible for storing the actual data blocks in HDFS. See, I'm stressing you here, guys. It is going to store data in the form of blocks. And each slave also have node manager. Look at here. So we have a node manager. So this component is the slave part of YARN. So this is the slave part of your YARN. Try to understand this. And it is responsible for managing the resources on that specific node. See, this is a separate computer, right? So in this computer also we have some resources. So who is going to handle all these resources? This is going to handle all the resources. So this is handling entire cluster. This is handling individual system, individual commodity, okay, or specific node. And it is responsible for running the task assigned to it. And finally, guys, below this, so we have map and also reduce task. So this is other application tasks are now run on the slave nodes and managed by, this is completely managed by this node manager. So I think everyone understood this, right? This functionality is very, very important one, guys. So all these functions are very, very important. So is this clear to everyone? I want each and everyone to confirm now. I want each and everyone to confirm now. All the components are crystal clear. All the components are crystal clear. Okay. So now, guys, I just show you guys. I just show you commands here. See, look at here, everyone. So maybe this window is visible to everyone, right? So here, as I told already, we have installed Hadoop system. So in my own system, I have installed Hadoop system. So now I'm going to show you how to start all the daemons. Last class I've shown you, right? What is the command we are going to use to start all daemons, guys? Yes, to start all the daemons, what command we are going to use? Not star. What is that star? Start. Okay, start sh, not start sh. See, you have to remember start yarn.sh. Okay. No, I have to run all the daemons. See, suppose one by one I'm running means, guys, actually look at here. Let me write here. Otherwise, you people will forget. Yes, very good. So many people are giving correct answer. First, we will start with the start dfs.sh and then start yarn.sh. Either you can start with this or you can start with this, or you can use only one command, that is start all.sh. Okay. Yes, many of them are giving correct answer. Now I will show you guys. Look at here. So here it is already started. So I've started with this start all.sh. So once you are starting all.sh, so it is going to load all the daemons. To view that daemon, what command we are going to use, guys? What is the command we are going to use to view all the daemons? JPS. Very good. So Java Virtual Process Status. Correct? No? JPS. Java Virtual Machine Process Status. See, look at here, everyone. You are finding all the components here. Name node, secondary name node, data node, node manager, resource manager. All the components are present here, guys. Yes or no? Quickly. Guys, you can check one by one also. Suppose you have to check one by one means you type JPS, then pipe symbol, type pipe symbol, and next to that you can type grep. So next to grep, you can type resource manager. Resource, sorry, what is the spelling? Resource manager. So this command I can type, guys. So individually I can type. Once I'm typing this, so this will what? Check if resource manager is running or not. Suppose you have to check with name node. You can check with JPS, pipe, grep, name node. And finally, you can type JPS. So JPS will check all Hadoop related processes. So running in background. So is this clear? Is this clear to everyone? Yeah, resource I have typed wrongly. So it is showing, correct? No, resource manager. So this process is running, right? Look at here, 9579 resource manager. This is the ID. Is there any way to run JPS on slave on master? Actually, see, this is the single node system. Suppose you are running on multi-node system, means guys, actually whatever the virtual lab we have provided for you people, that is multi-node system. So in multi-node system, it is not going to list all the nodes. See, your data node and node manager is going to display on slave nodes. So only name node, secondary name node, and resource managers are going to list on master node. Understanding? So that is there in your virtual lab, guys. In your virtual lab, you are going to get separately. But since I'm using what single node system, so it is showing everything here only. It is a kind of pseudocode, guys. It is a kind of pseudocode. So is this clear to everyone? Is it showing everything, whatever I've explained you? Yes or no? See, look at here. See here, in slave node, you are going to get data node and also node manager. Once again, guys. In slave node, it is going to show only data node and node manager. In master node, it is going to show name node, resource manager along with that. So it is going to show secondary name node. That I will show you later. Secondary name node is not present here. I will show you later. So till here, everything is clear. Till here, everything is clear. Yes or no? So now you can see here, guys, these are the two differences between Hadoop 1 and also Hadoop 2. So both I have clearly mentioned here. So this is very, very important slide because understanding the key differences between Hadoop 1 and Hadoop 2 is a fundamental to understanding the evaluation of big data system. Okay, look at the diagram. Directly look at the diagram. Instead of seeing this explanation, look at the diagram. See, Hadoop 1, as we discussed, so MapReduce was tightly coupled with resource management and data processing. So this was a major limitation. Okay, it will be having what? The single name node was also a what? Single point of failure. Correct, no? If the name node went down, the entire cluster become unusable. How many of them will agree with my point? So it is only supported MapReduce program, right? And now you just look at Hadoop 2. See, Hadoop 2 is containing, see, the biggest change. So is the introduction of YARN. See, YARN is introduced here. Look at here. So we have YARN here. Resource manager, we have separately. YARN now handles the resource management. And MapReduce is just data processing. It is going to perform data processing framework that runs on top of YARN. And this decoupling is a what? Huge deal. It allows you to run other types of jobs like Spark, any other job we have to performance, we can perform very easily. And Hadoop 2 also addresses this SPOF issue of the what name node by introducing high availability concept. High availability concept. Some I have told you, right, fault tolerance that I will explain you later. Okay, high availability configurations with an active passive setup and another mechanism. Okay, active passive setup also I already explained in the previous session. Another key point is that Hadoop 2 now supports for non-HDFS storage. It is not only supporting for HDFS storage, it is supporting for non-HDFS storage. Guys, what is the advantage of using this? What is the advantage of using this, guys? You can run jobs on data stored in systems like Amazon S3. Okay, so is it not good, guys? So this gives you what? Lot more flexibility. Not only it is working with HDFS, so I can store Amazon S3. I can access Amazon S3 from here. I can access any other devices. NoSQL also I can access here. Okay, so this is the what small difference I have told you, guys. So you want more differences on this means you go through the what internet. So you are going to get more informations. Okay, in Hadoop 1 there is one secondary name node. Okay, where is Hadoop 1? Where is secondary name node? Where I have mentioned secondary name node here. Secondary name node is present here only, guys. I will show you in the next diagram. Okay. Now look at here. So these are the Hadoop distributions. So quickly I will go through this. So you have Apache Hadoop, Intel distribution, Cloudera. Maybe you have heard about this. MapR, EMC Greenplum HD, MS Big Data Solution, IBM InfoSphere Big Sites, and Hortonworks. So these are the different distribution we have with respect to Hadoop. Okay, guys, one more thing. When we talk about Hadoop, we often mean the open source Apache project. So it has 4 components, guys. So one is Hadoop Common. So this contains common utilities and libraries that support the other modules. And next one is HDFS, Hadoop Distributed File System. And third one is Hadoop Yarn. And fourth one is Hadoop MapReduce. Okay. Now, while the Apache project is the core, many companies have created their own distributions. And these distributions are essentially the core Apache Hadoop plus a bunch of other tools and services like management interfaces, security features, support contracts. Okay, think of them as a what complete enterprise ready package. Okay, so example for that is everything we have mentioned here. So these are all the examples. Okay, the very, very important one is this Cloudera CDH and Hortonworks. So these companies make it easier for businesses to adopt and manage Hadoop by providing a full-fledged platform. So this is a crucial point, guys, because in professional settings, you are more likely to work with one of these distribution than with the what? Vanilla Apache installation. Okay, vanilla Apache installation. So you please work on this, guys. This is again very, very important one. Okay, so let's now move on to the core of discussions for the rest of the HDFS concept. Till here, everything is clear. Shall I get the confirmation? Till here, everything is clear. Till here, everything is clear. Quickly, guys. Sir, can Python be used or will it be only Java? Tanya, I'm using Python. I'm not going to use Java. Okay, I'm not going to use Java programming. In entire my session, I'm going to use Python. So yes, I can write program by using Java also, but Java, see, we have to write mapper code, we have to write reducer code. Along with that, every time we have to write driver. And hardly it will take 100 plus lines. So in Java, we can write by using 20 plus lines. So that's why I'm feeling very good at Python programming. So throughout my concept, I'm going to use only Python. Tanya, is this clear? Is this clear, Tanya? Yeah, see, that is what I'm telling you. Actually, see, we have a what jar file. With the help of jar file only, we are going to run all the programs. Okay, that I will show you later. No need to worry about that. Guys, that's it about the first two part of this. So now we are moving moving into what very important concept, that is Hadoop HDFS. Okay, that is a kind of what storage. Okay, so look at here, guys. My dear friends, let's start with the key features of HDFS. I have taken 4 slides to explain on key features. So let me give you one by one in detail. Okay, first, HDFS is a distributed file system. It is a distributed file system. The meaning of this is it stores data over multiple nodes in a cluster. But it provided a seamless experience to the user. So it gives you the what illusion that all the data is on a single massive machine. Okay, so this is a crucial for simplifying the programmer's job, guys. Guys, HDFS is a Java-based DBS. My friends were asking, right? It is a Java-based DFS. So it sits on top of native file systems like EX2 or EX3. So it is managing the what storage of data blocks within it. Who is going to manage this? Either EX2 or EX3 is going to manage all the data storage, data blocks. And the main purpose of HDFS is to enable the storage of very large files across the cluster. The meaning of this is data split into large blocks. Okay, data split into large chunks. That large chunks are called as blocks here. Guys, in Hadoop 2.0 or 2. Whatever you want, the default size of a block is a very large, guys. That is 128 MB. Try to understand this. You people were asking me to what type of question you are going to give, right? So you have to remember all these points. Okay, EX2, EX3 file system. So if anybody is good at EX2 and EX3, please answer to Pradeep. Okay, please answer to Pradeep. So I'm moving forward. Guys, here the block size is 128 MB. This is very important point, guys. So based on this, you are going to get problems in the examination. Try to understand this. So I'm giving you hint. Guys, you can ask me the question, right? Sir, why such a large block size? So why 128 MB? Correct, no? Well, think about it, guys. If you have a terabyte sized file and you break it into 4 KB chunks. See, normal file, See, in normal file, we are going to use 4 KB chunks, right? Suppose you are dividing 1 terabytes of data or 1 petabytes of data. So in 4 KB chunks means, you just imagine, guys, how many billions of blocks you are going to get. Are you getting my point? You would have billions of blocks, right? And imagine how your name node is going to maintain metadata for all these blocks. Is it not huge? Would overwhelm the what name node, right? And by using a large blocks, we reduce the amount of metadata that the name node has to manage. So that is the very first feature, guys. And the second feature is scale through the parallel data processing. Okay, so let's say you have 1 TB of data, 1 TB file on a single machine with an input output bandwidth of 400 Mbps. So it would take you about what, guys? 43 minutes of time. So 43 minutes of time to read the what? Read the whole file. But if you store the same 1 TB data, so 1 TB data on 10 different machines. So this is on single machine. For single machine, it is taking 43 minutes. Suppose you are storing 1 TB of data in 10 machines and process them in parallel. You can do the same task in just 4.3 minutes, right? Guys, this is the power of parallel processing that used in HDFS concept. This large block size and parallel processing are what make HDFS so suitable for big data system. So hope you are understanding, guys. Is it not interesting? Is it not interesting? So if it is interesting, please do type me on chat box interesting. Okay, let me go with the second feature. I was telling about fault tolerance, right? Now I'm explaining you on fault tolerance, guys. And this is also very important one. Guys, I'm telling you, based on this, you are going to get questions in the examination. Okay, so this is the second feature. The second feature is fault tolerance through replication. Listen to me, fault tolerance through replication. So this is a core tenet of HDFS. Since we are using commodity hardware, node failures are not an exception. Okay, that is, they are an expectations, right? To protect against this, HDFS replicates each data blocks across multiple nodes in the cluster. Okay, that is the reason why we are replicating the data. And the default replication factor is 3. Look at here. The default replication factor is 3. What is the default block size? Default block size is 128. What is the default replication factor? That is equals to 3. See, I'm repeating. So this means, so if you store 1 GB of data in HDFS means, actually it will consume 3 GB of storage in the cluster. So this might seem like a lot, right? But it is a necessary trade-off for data durability. The meaning of this is, if one of the data nodes goes down, we still have 2 other copies of data block. So no data is lost here. This is a very important concept, guys. And another key feature is consistency. Already I've told you about consistency, right? So here we are going to use write once and read many times workload. The meaning of this, already I've told you, right? The meaning of this is, you can write a file to HDFS once and then you can read it as many times as you want. However, you cannot just open a file, update it at the arbitrary point. You can append data to an existing file or truncate it, but you cannot modify it in a middle. Guys, this design choice simplifies the consistency model and makes HDFS very efficient for large scale data processing. Okay, now look at here, guys. Next slide, I'm explaining you on cost and data volume. These are the next features. Okay, let's talk about two very important features. The very first one is cost. The beauty of Hadoop is that it is designed to run on commodity hardware. The meaning of this is you can use a standard inexpensive server to build a massive cluster. Hope everyone will agree with my point. This drastically lowers the total cost of ownership. So usually we are going to call it as TCO, total cost of ownership, compared to expensive specialized hardware. When you need to add more capacity, you just add more commodity nodes, which is very cost effective, guys. And the second one is, what is the second feature? Variety and volume of data. Variety and volume of data. This already I've told you, right? So HDFS is built to handle huge data sets in the terabytes and petabytes. This is a primary use case. So it is not suitable for small files, as the overhead of managing a large number of small files can be significant. It excels at storing and processing huge semi-structured and unstructured data sets. So hope everyone understood these two features. So is this clear, guys? Shall we go with the next slide? So we have few more features. Till here everything is clear. Till here everything is clear. So now look at here. So two more features we have here. One is data integrity and another one is data locality. Guys, data integrity, HDFS is not just about storing data. It is also about ensuring that the data remains uncorrupted. Okay, guys, here the very interesting thing is the HDFS nodes constantly verify checksum. Constantly verify checksum. So think of a checksum as a unique fingerprint for a data block. See, this is your data block. So for this data block, you will be having unit fingerprint. So unique fingerprint for each and every data block. When a block is written, a checksum is generated. So once you have written something, then immediately checksum of that particular block is going to generate it. So when a client read the block, the checksum is verified. At the time of read, so it is going to verify the checksum. So if there is a mismatch, so it indicates data corruption. And a new copy is created from the uncorrupted replica. See, we have stored on different machines, right? So we'll take the data from the other node, other replica, and so we are going to replace that corrupted copy. So this mechanism is crucial for ensuring the reliability of our data. So that is called as data integrity. And next we have data locality. So this is the core concept in the Hadoop philosophy, guys. The idea is to move the processing to the data. Okay, the processing unit to the data rather than the data to the processing unit. You can ask me the question, why, right? Guys, imagine you have 1 TB of an server in your cluster. So if you want to process this file on a different server, you would have moved to the entire 1 TB of data over the network. Am I right or wrong, guys? So this would be incredibly slow, because you are moving 1 TB of data. So this is incredibly slow, right? And it would consume a huge amount of network bandwidth. Am I right or wrong, guys? So instead, in Hadoop, the processing tasks are sent to the nodes where the data blocks are already residing. So you are not moving the data at all. You are just moving the small program or processing part. So this drastically reduces network traffic and speed up the entire process. This concept is fundamental to why Hadoop is so efficient for big data. Make a note of this, guys. This is very, very important point. So this concept is very, very important. That's why every time we are going to type mapper and reducer program on a different system, we are not going to move any data. Okay. So finally, guys, here I'm showing you the complete architecture of your HDFS. So with respect to your master data, master nodes, with respect to your slave nodes. So till here, everything is clear. Can I get the confirmation and chat box? Can I get the confirmation and chat box? Am I making sense to each and everyone, guys? Am I making sense to each and everyone? You're all with me? You all with me, guys? Now I'm going little deeper with respect to your HDFS architecture, guys. Okay. So it is a what? Classic master slave architecture. Try to understand this. So there is a single master node. Okay. There is a single master node that runs the name node daemons. Okay. This is the master node. This is running the what? Name node daemon. The name node is the brain of HDFS. Already I've told you. And it is responsible for managing the file system's namespace. Okay, it is managing the file system namespace. That is file name to the block and the replica mapping, everything, guys. Okay. And what, see, you can ask me, guys, it keeps track of what? All the directories, all the files, the mapping of which block being to what, which file. So it also knows where all the replicas of each block are stored on the slave node. It will be having all the information. So in which block I've stored the information, all the informations are going to maintain by the name node. Already I've told you, right? Name node is arbitrator. It does not handle the actual data flow. When an HDFS client wants to read or write a file, okay, here, look at here. So if any of the client wants to read or write a file, so it first talk to the name node to get the metadata. Look at here. It will talk to the name node to get the metadata. For example, a client wants to read a file. So it asks the name node. So where is this file? The name node respond with the list of blocks that makes up the what file and addresses of the what data nodes that hold these blocks. Okay, the client then directly talk to the data nodes to get the data. So hope it is very interesting, correct? No? Okay, the client then directly talk to the data node to get that particular data. Is it not interesting, guys? Is it not interesting? So this is very crucial point, guys. The name node manages metadata and the data node handles the actual data. This separation of concerns makes the name node very efficient as it does not have to deal with the huge volume of data traffic. So is this clear? Is this clear, crystal clear to everyone? See, look at here, guys. Let me show you one command to show everything practically. So you have to type HDFS space get config. This is the command you have to type. Please note down these commands, guys. Get config, and then you have to type name node. This is the command you have to type, guys. HDFS get config. So in short form, config and name nodes. So it is used to find the host name of the active name node. Okay, once you are clicking on this, so it will show the active name node details. Look at here. It is showing all the details. So here I'm getting some error. So why I'm getting some error? Get config. What is the spelling? Get. Okay, conf, guys, not config. So it is, sorry, here I've made a typing mistake. Conf. Okay, just conf. That's it. Not config, just conf. Yeah. Here, look at here, guys. Look at here. It is showing you the information. So get config name nodes. What I've typed here, name nodes I have to type, right? So why I'm doing so many mistakes? Okay, it is asking me for error. Okay, look at here, guys. This is the name of the name node. Once again, let me show you in fresh page. See here, unable to load native Hadoop library for your platform. It is showing some warning, guys. It is showing some warning. So this is the exactly node name it is showing, guys. Desktop J6 KCUOA. So this is where it is loaded my name node. Okay. Or else to view the content of HDFS configuration, to see master node information, you have to type again same thing. So conf, immediately after conf, you have to type hyphen conf key, conf key space DFS dot name node, DFS dot name node dot HTTP address. HTTP address, I think it is Hadoop master. I have given it as a Hadoop master. I think so, guys. I forgot that name. HTTP Hadoop master I have given. Okay, somewhere I missed, guys. I don't know the name of the Hadoop master. So once again, let me check with my system. It is Ubuntu worker, Ubuntu master. I don't know the name. I forgot the name at the time of installation I've given. Ubuntu master, I think so. Ubuntu master. Okay. I missed with that name, guys. Actually, I'm not giving the correct file name. So somewhere I've given the name, guys, but you are giving that master name means immediately it is going to show the content of the HDFS configuration to see the master node setting. Okay, I will give you correct command. So once I am running with the correct name, so then I'm going to give you correct name, guys. So this is how you are going to check your master node information. Name node spelling. What I have typed here. What is the spelling I have typed here? Oh, okay. Usually I'll do spelling mistakes, guys. Then let me try with this. Yeah, Ubuntu master is missing. Is it Hadoop master? Actually, I've worked on both the system. So there I have given Hadoop master. I have used Hadoop master name there. So here I'm not getting. Okay, so you just remember this command, guys. So to check the content of HDFS, so for your master node, you have to type this command. That's all. That is what you have to remember. So here I'm not getting correctly. So there, in your computer, you are using the same means you are going to get the correct information. So is this clear with the master node? Is this clear with the master node, guys? So you have any doubt in master node? So shall we move to slave nodes? Shall we move to slave nodes? Yes, quickly. So this is our slave nodes, guys. Look at here. So see, this is another side of what your HDFS architecture, that is slave nodes. Okay, there are a multiple slave nodes in a cluster. See, look at here. So here I have a separate node. Here I have a separate node. So we have multiple slave nodes here. Understanding my point, guys? So each one runs a data node daemon. So each one runs a data node daemon. A data node is the workhorse of HDFS, and it is responsible for the actual read and write operations on data blocks. Understanding my point, guys? So the data nodes also serve the other request from the name node. Okay. So such as creating a new block replicas. deleting blocks or replicating a block to a what new node to maintain the what replication factor. So your data node is going to what serve request from the name node. The key point is that data nodes communicate with each other. So one data node is going to communicate with another data node. This is very interesting thing. So this is essential for the what? Pipeline reads and write that we discuss later. See, for example, in write operation, the client sends a data block to one data node, and that data node then forward it to the what? Next data node in the pipeline, and so on and so forth. Guys, unlike name node, the data node do not require any additional high availability setup because the data is already replicated across multiple data nodes. If one data node goes down, its blocks can be recovered from the other replica. So in short, the data nodes are the storage units that do the what heavy lifting of storing and serving data blocks, while name nodes manages the metadata. So now you can ask me, sir, what is the functions of name node? See, here I'm listing few functions of name node, guys. How FT is archived for master node and configuration. Ravi, I will show you everything later. Okay, you just look at the understand the concept. So here I'm trying to explain what is slave node, what is master node. That's all. So later on you will get answer to each and everything. Okay, wait for a while. Okay, so now look at here, guys. Now look at here. So now this is another very, very important one. Functions of name node. Okay, functions of name node is very, very important. So let's take a closer look at the what functions of the name node. Guys, this is very, very important one. The name node maintains the HDFS namespace using two crucial files. Okay, two crucial files. One is FS image. This is very, very important, guys. One is FS image. Another one is edit log. Guys, this FS image is a file snapshot. Okay, it is a file snapshot of the file system metadata. It contains the mapping of files to their blocks. Try to understand. Mapping of blocks to their particular file. So files to their blocks, the directory structure, and the properties of the file and directories. Everything is going to what? Maintained by this FS image. And look at the next one. Next one is very interesting. Edit log. So this is the transaction log that records every single change made to the metadata. If we are making any change to the name node means that is going to maintain in edit log, not in FS image. Try to understand this. So for example, if you create a new file, that change is immediately returned to the edit log. Understanding my point, guys? And it is very, very important to remember that the name node does not store any data. Correct, no? So it only stores metadata, that's it. Because of this, the name node's memory footprint is relatively small and it can load the entire FS image and edit log into its memory for fast accessing. Guys, you can observe here, the name node constantly receives, so this is another very, very important point, guys. Try to understand this. So this name node constantly receives periodic heartbeat and a block report. See, guys, this heartbeat and block report. This is very, very important. So your name node constantly receiving these two things. The heartbeat tells the name node that the data node is alive and well. The block report is a list of all the blocks stored on the data node. So who is giving all the block information? This block report is giving all the information of data node. This allows the name node to have a complete and up-to-date picture of their entire cluster. Guys, you can ask me now, sir, if a data node fails, guys, if data node fails, the name node detect this via the missed heartbeats and take some actions. It chooses new data nodes to replicate the what lost block to maintain that required replication factor. So it also manages disk usage, communication traffic to the data nodes. Okay, so how many of them are feeling this is very, very important concept? Guys, this is very, very important topic. The name node is a complex, robust system that is the central authority in HDFS. Yes or no, guys? Yes or no? See, here you can see. So this is how the FS image and edit logs are going to show. See, look at here, everyone. This is how it is going to show FS logs and also edit logs. Okay, this you have to search in your Google, guys. Sorry, not in Google, in your system. That's why I told you to what? That's why every time I'm telling you people to install by yourself. So once you people are installing your operating system, then you'll be knowing this address. So home, Hadoop data, HDFS, name node current. So once you are searching for that particular FS image and edit log, so then you have to search in this path actually. Clear, guys? So this will show you all the information. So inside this, you will be see this is edit log actually. See these are all FS image. I've told you, right, what is FS image, what is edit log. So whatever the changes you are going to do, that is to be what recorded by this edit log, not by FS image. Is this clear? Is this crystal clear to everyone? Yes or no? That's why I'm requesting each and everyone to what install by yourself. Then you will be knowing where exactly you have stored name node. So go to that name node. Inside that name node, it is going to create current folder. So inside current, you'll be having all the information about FS image and also edit log. Okay. Is this clear? Yes or no? And look at here. So all these FS logs, sorry, FS images are the snapshots and the edit files are the transaction logs. All these edit logs are the transaction logs actually. The number in the file name represent the unique transaction ID. Look at here, 200, 102, 104. Okay. The number in the file name represent the unique transaction ID. And FS image MD5, you can look at here. FS image is having the extension MD5, right? So this is the what checksum file. I was talking about checksum file, right? So this is checksum file to ensure the integrity of the FS image. So this is a great example of built-in data integrity checks. Okay. Data integrity checks, guys. So we had talked about earlier, right? So even at the metadata level, guys, the fact that you can see these files in the file system reminds us that HDFS is not a magic. So it is a sophisticated system built on top of native file system to manage distributed storage. Understanding my point? Ravi Kumar, am I making any bore? Am I not making, I'm not making the class interesting? If you want me to close the class, I will close. If I'm boring you people, then I will close the class. See, already I've told you, right? I've given 10 minutes break. Ravi Kumar, is there any problem with you? Okay, it is about time. So what about others, guys? Should I stop the class now? So you have to come, see 70 slides are there totally. So still I'm in 29 slide. So some of the concepts are very, very important. That's why I'm prolonging. See here, some of the diagrams you have. It will take very less time to complete. Again, I'm coming up with 30 slides in the next coming class means. So entire 2 hours I'm going to spend on first 30 classes only. Correct? No. So everyone are feeling bored, guys. So if you people are feeling bored, I will close the session now. I want opinion from each and everyone, guys. I want opinion from each and everyone. It is not only about Ravi. I'm asking opinion on all. So we have so many important concept. So why no one is responding? Sir, in my opinion, so we should stop today. So as we are already across too many concepts for the day. So we have a revision also, sir. So today we have 3 classes, tomorrow also 3 classes. So no problem, guys. I will go with you people only. So if you want me to stop, I will stop the session. So let me complete 2 more slides, guys. So that will cover at least first part. So let me complete 2 more slides. So I will take this slide, and this slide. That's it. So I have 3 slides. Is it okay for you all, guys? After these 3 slides, I'm going to stop the session. Okay, so only 3 slides, guys. I will take another 5 to 10 minutes. That's it. Is it okay for you all? So let me complete at least one part. Okay. Okay, now look at here, guys. Name node. What happens on startup? This is again very, very important concept, guys. So I want you people to focus on this slide, guys. Guys, what happens when a name node startup? So this is another interesting concept, guys. I'm telling you again and again. First, the name node enters a safe node. Look at here. First, the name node enters a safe node. During this time, it does not allow any data replication. Guys, it is read-only state. Okay, it is read-only state. Okay. So what it doing in safe mode? You can ask me the question, right? So what is it doing in the safe mode? Guys, it checks the status of all the data nodes. That is one thing. Second thing is it receives the heartbeat and block report from all the data nodes. That is the second one. And third one, it ensures that the minimum replication factor. See, look at here. The minimum replication factor is met for majority of the blocks. So this is a configurable setting that ensures the cluster is in a healthy state before it start allowing write. Then guys, it begins a process called checkpointing. And try to understand this. I'm going very slowly. So it is going to look at the checkpointing. The meaning of this is it reads the FS image. Look at here. It reads the FS image and all the edit log from disk into memory. It then applies all the changes. See, first it is loading these two. After loading these two, so it applies all the changes from the edit log to the in-memory version of the FS image. So this creates a new up-to-date in-memory FS image. Correct, no? So it then flushes this new version of the FS image back to disk. The old edit log is then truncated because its changes have been incorporated into the new FS image. So this process is crucial because it prevents the edit log from growing indefinitely. So once this is completed, the name node exit the safe state and is now ready to handle client request and further replication. Okay, so this startup process is testament to the name node's robustness and its ability to recover from a shutdown. Okay, and look at here, what are the functions of data node then? So now we are shifting our focus to the workhorse of HDFS, that is nothing but your data node. So as we discussed earlier, so each slave in cluster runs a data node. The data node are where the actual data blocks are stored. They store the blocks as regular files on the native file system. So somebody was asking about this, right? ext2, ext3. So that is we are going to use in Windows operating system to maintain the complete file system. Okay, so even in individual system, we'll be having the same thing. Okay, the data node are responsible for, what is the responsibility of data node? The responsibility of the data node is serving read and write request from HDFS clients. In a write operation, the data node communicate with each other in a pipeline to transfer the data. Okay, here, so look at here. This name node is going to talk to this name node. This name node is going to talk to this name node. Why it is communicating? Can anyone tell me why it has to communicate with other nodes, data nodes at the time of writing? Can anyone answer? So you have understood the concept, what I've taught means, then definitely will answer to this question. Why we have to communicate with other data node? Yes, we have maintained replica, right? Not for synchronization purpose. So we have maintained replica. So we have maintained replica in a different data node. So block C, by default, I've told you what 3 replicas, right? Are you getting my point? The data is already replicated across multiple data nodes, guys. There is no need for any additional high availability setup for a data node. If one fails, the name node detects it and initiate the replications of the lost blocks. Guys, the data node is repeated, relatively simple component. It is its main job is to listen for request from the name node and from the clients and to perform the requested action on the data blocks. This is first function. And the second function is listed here. Look at here. Second function, look at the couple of other key functions of data node. The data node continuously sends what, guys? The data node continuously sends heartbeat to the name node. Correct? No. Guys, this heartbeat is a small periodic message sent every 3 seconds by default. Every 3 seconds, guys. By default, it will send every 3 seconds. So it is a way for the data node to tell the name node, I am alive. Okay, I am alive. If the name node does not receive a heartbeat from the data node for a certain period, it assumes the data node has failed. It then removes the data node from its metadata records and start the process of replicating the blocks that were stored on the failed node on other data nodes in the cluster. Guys, here the data node also send block report to the name node, both on startup and also periodically. It will send at the beginning also. It will send afterwards also. The block report is a list of all the blocks that the data node is currently storing. So this allows the name node to have an accurate map of where all the blocks are located. Okay, the data node itself has no knowledge of HDFS level files or directories. It just sees a bunch of local files. So which are the data blocks. The mapping of which block being to which HDFS file is the function of name node. It is not the function of data node. Okay, so this conclude the overview of name node and also data node functions, guys. I got one question from Pradeep. So data node has replica, so having backup. If any fails, it maintains HA. No HA it is going to maintain here. See, HA with respect to name node. How come it is with respect to data node? So only with respect to name node, guys, not with respect to data node. Pradeep, hope you are getting my point. HDFS will always see, sorry, your data node will always take care of data blocks. That's it. So what and all data blocks are stored. So if it is getting any information, it will pass to what next one. That's all. That is the job of data node. Okay. So that's all for today, guys. Actually, we have discussed about the complete architecture. Under architecture, we have talked more on. We have discussed more on this robustness. So next class, again, it is very, very important concept. So I'm going to introduce one more. See, my friends are asking about secondary name node, right? So secondary name node, I'm going to explain you in the next class. Jyoti, just now I told you. Secondary name node concept is there, right? Yes, we have. That I'm going to explain in the next coming class. So that is responsible for this HA. So Pradeep is going to get correct answer in the next coming class. After that, blocks in HDFS is very, very important concept. So based on this also, you are going to get some problem in the examination. So replica concept also very, very important. HDFS data write and HDFS data read. So these two concepts are very, very important. Security concepts are there, file systems are there. And then we have few basic commands that this I have not shown you today. See, all this concept we are going to discuss in tomorrow's session, guys. Okay. I will try to complete syllabus by the end of what 8 session, guys. I have to complete because already we have framed question paper. So we have to complete all these sessions concept. That is must. So I want you people, your cooperation, guys. Without your cooperation, it is very difficult to complete the syllabus. Okay. So I sincerely request. So get ready with what the extension of you come out with the what mindset of extension of class, guys. So then only I can complete the syllabus. So I don't want to skip any one of the concept because guys, so whatever the concept I'm going to teach you, that is very, very important for you people. Without understanding this, see, once I'm showing you any practical thing, so by default, it will do in background, guys. But in an interview, they are going to ask you more questions on big data. Okay. So that's why I'm giving you each and every information in detail. And I'm not reading any of the slides, right? Am I reading any of the slides? See, here we have so many concepts. Am I reading any slides? So instead of reading, I'm elaborating on that, right? So each and every point I'm explaining you people with example. So that's why it is taking too much of time. Ravi, I can understand. I can understand. See, you should dedicate. So dedication is very, very important. It is not too lengthy syllabus. We are trying to give you more knowledge on big data tools. Why you people are not understanding? You are not learning big data analytics. So analytics means directly we will jump to concept and we will show only practical things. You people are learning big data system. See, big data system is going to give you the complete knowledge on big data tools. Without this knowledge, it is very difficult to understand the tools. That is the reason behind that. Okay, you people will understand later, guys. So now I'm telling you something. You people see, you people are always thinking on examination. See, examination is not important. So knowledge, what you are gaining is very, very important. Correct? No. Okay. Yes, no problem, guys. So next class, we are going to continue. So anyway, tomorrow we have a class. So let me finish this HDFS part first. and then I will jump to MapReduce concept, that is in 7th session. So I will try to complete, guys. I will try to complete 8 sessions. Okay. Before 8th session, I'm going to complete all the syllabus. Okay. Thank you all, guys. Thank you for your cooperation. Again, I've taken 30 minutes extra class. Sir, we are not pointing on your teaching method, but too many concepts. No time for practicing and learning. All things getting mixed up. So it is getting hard for us. So what I should answer? I don't have any answer. That's all. Okay. Think on getting degree also. Okay. Yes. Thank you, guys. So give me one line feedback on today's session. So with that, we are going to conclude today's session. I tried my best to give you all the knowledge, guys. That's all. So give me one line feedback on today's session. So with that, we can close today's session, guys. Thank you all, guys. Thank you for your patience. Thank you for your time on extra class. So do we have further classes between regular dates and makeup dates? No. I'm not getting your point, Saini. Do you have further classes between regular dates and makeup dates? What is that? How questions comes in exam, sir? Any format like theory, numerical? Okay. Pradeep, already have conveyed this. So maximum you're going to get case study based questions, numerical problems, and theoretical based. So mixture of all. No. You asked me the question, Saini. I did not understand your question.